Hi, everyone. Good morning, good evening. Thank you so much for coming to Girls for STEM. We really do appreciate. And guys, today we are commemorating Science Day, Girls and Women's Day. So thank you so much for coming to this channel, guys. We really, really do appreciate. So if you're coming here for the first time, you know what to do, guys. So as you can see, my table has some few experiments that we are going to run. So again, welcome to Girls for STEM. And today we're just commemorating Science Day. And we have engineers here that are going to showcase some of the science experiments that kids can work on. So you know what, we're not going to waste so much time. So I have about 2-3 people, scientists, that are going to join us. And yeah, so just a second. And as you can see, yes, I would like to say hello to my friends who are watching. Hi guys, Alfeo Mwenda, thank you so much for coming. I really appreciate Alfeo for supporting. You always here. And Mambwe, oh my God, Mambwe, thank you so much for coming. I really do appreciate Mambwe. She always come. Kimberly, yeah, because she uses her mom's name, I think. So thank you so much. There is Mubanga there. Thank you so much, guys, for coming. So yes, today is Science Day, and it involves women and girls. So on this channel, we thought of trying to do some experiments just to, to encourage girls that even at home, at the comfort zone of your home, you can still do some experiments that are cool. You can do virtual experiments. So we have an exciting virtual experiment from one of the upcoming astronauts, Priya. We have an experiment from an engineer, Jeshana Jones, and we also have an experiment from Mukosha. Hopefully he can make it. He's trying to get online. You know how it is, guys. We deal with different people from different countries, so sometimes it's a little bit challenging. So we're going to get into the experiments right away. I hope we're going to have fun. So guys, I have a very cool experiment here that I'm going to showcase. So if you're coming here for the first time, again, this is Girls for STEM. My name is Kirsten. I'm an engineer in the aerospace company, and I'm very passionate about encouraging girls to pursue science and technology. So make sure you can comment. If you have a question, comment. So this experiment, I think we did it with the young ones when I was in Africa one month, maybe a few weeks ago. But other than that, yes, we need to learn how to do experiments in the house. Guys, do you know what this is? This is apple cider. This is vinegar. It's also called vinegar. That's what I have. And I also have baking soda. Guys, this is easy. So why do I have almost like home stuff that we can ignite girls to pursue science and technology? So we don't have to buy expensive things. We don't have to think, oh, we cannot pursue science because we don't have resources, things like that. So you're going to see how other candidates on this show, what they are going to showcase. So that's why I took, this is baking soda from the house, and this is just apple cider from the house. So what do these two products do? That's what we're going to try now and see what they do. So let's try. Guys, make sure you can comment. If you have a question, ask. Feel free to ask anytime. So I am going to try and see what does vinegar and baking soda do, right? So let's go ahead and try. So that's vinegar, guys. I'm going to pour it. Hope everybody can see it, guys. I'm going to pour it in here. Okay, so we're just trying to see what does soda, baking soda, and also apple cider do when they mix together. So I'll give an explanation afterwards, but we just want to see the reaction. So I'll just put it here, and I'm going to get some soda. Whoa, guys, can you see that? Hopefully you can see. Interesting. Hissy. It's hissy and I can smell it and it's hissy and it looks like it produced gas. So when we mixed vinegar, which is an acid, if you remember, and baking soda, when we mixed, it produced some gas and it made hissy. So that means it's gas that was produced. So now, what do you think can happen? Because I would like to capture that gas that was hissy and I could smell it. So I'd like to capture it. So how do I capture that gas? That's interesting. Again, guys, if you're coming here for the first time, if you're just coming in, I just mixed vinegar. I poured it into my, it's like a vase. And I also, first I added baking soda and it produced a hissy sound. A hissy sound, that means there was some gas coming out. Again, these are household products that I'm using. I have not bought anything. We use baking powder to make cakes and scones. And we also use baking powder for in Africa to make so many things. A lot of things, guys. That's food that we do make. And this is vinegar. We use it to put on French fries, your salad. So, these are easy things that you can use. Okay. So now that I saw that it made a hissy sound, I heard the hissy sound, that means it produces gas. So what can we do? So this is what we're going to do. I would like to capture that gas to make sure if it's a gas that comes out. Okay. So I'm going to put this aside, okay? And I'm also going to bring these two again. And guess what I have? I have this little vase. So let's see what this little vase can do. In fact, guys, I was supposed to be wearing glasses. My apologies. How do I look, guys? Yep, that's right. I need to wear glasses, guys, when I'm performing experiments. So let's see what can happen, guys. I am going to pour, because I would like to capture the gas that came out when I added vinegar and bicarbonate soda. I had a hissing gas and it was stinky. Okay, so now I am going to pour now the vinegar again into my little cute container up to just there. Hopefully, let's see how this is gonna work. Again, guys, this is vinegar. You can get it anywhere, guys. You know what I'm saying? Vinegar. Make sure if you are a kid performing this experiment. Hi, Cecilia, I can see you. Hi, Mom, Kimberly. Oh, thank you so much for coming. So, and this is baking soda. Easy stuff, guys. Easy. Make sure your parents are there because I know there are kids watching here. Make sure your parents are there. So we just put vinegar in this little bottle, guys. So what am I going to do? Let me see. Let me just make sure. So I have a balloon here, guys. Look, I have a balloon. So let's see if we can now mix that. So I have a paper. This is just a paper, guys. I'm going to make it into a funnel because I don't have a funnel. Look. So I'm going to do like this. Come on, don't disappoint me, Mr. Balloon. So I am going to, yeah. Guys, I just want to pour my soda in my balloon, okay? So here is my soda. I have a little cute spoon. It's cute. It's being used for something else, but who cares? So I'm going to pour my baking soda, just 1 teaspoon inside the balloon. Who remembers this experiment, kids? Leave a comment. Okay, it's inside, guys. It's inside. Oh, I'm nervous. What's gonna happen? I'm nervous, guys. This is my balloon. I wrote something there. Maybe you'll see if it's gonna open up. You're going to see. So this is vinegar, guys. Remember, vinegar. And this is bicarbonate soda. We use bicarbonate soda all the time, guys. I'm in the laboratory. Yes, Alfeo, I'm in the laboratory. So So, what I'm going to do is I'm going to put the mouth of the balloon on my little cute little tiny tingy thing. What do you call this, guys? I don't know what to call it, but it's my little jar. You know what I'm saying? So this is vinegar, and I added bicarbonate soda in my balloon, the baking soda. So now let's cover it up, guys. What do you think I'm doing, guys? Let me know. Do you know what's happening here? Okay, guys, you ready for this? So now, I added vinegar, and this is bicarbonate soda, and I'm going to now what? To start pouring it in here, guys. Watch this. Oh. Whoa, guys, look. Isn't that fun? Guys, I wrote this just for fun. Oh my God, this is so cool. Guys, you know why I'm wearing glasses? I don't want my eyes to be pricked. I want to stay cute like this. Whoa, so cool. Kids, did you see that? Wow. Okay, that's interesting. So, guys, what do you think? Okay, so I still have a little bit of some granules of bicarbonate soda at the bottom. And what do you think should make this balloon blow even bigger? What do you think? What should I do? Add more bicarbonate soda or add more vinegar? What do you think, guys? Oh, all right. Yeah. So what do you think, guys? Yeah, it's a beaker, but what do you think I should add for this for all the bicarbonate soda to disappear, because I see bicarbonate soda at the bottom and the gas has stopped, making the balloon blow. Wow. Did you see that, guys? That's so cool. So you see, this is just a little, I don't know what you would call this, guys. I don't know what I can call it and where to find it. Add more soda. I'm not sure if we add more bicarbonate soda, because I still have some bicarbonate soda at the bottom. It hasn't completely dissolved. It's not saturated yet. So, what do you think, guys? We should add. So again, this is homemade bicarbonate soda and this is vinegar. So we just did an experiment. Now, let me explain the experiment behind this. So I'm not going to go so much into this. So what happens is baking soda is a base and vinegar is an acid. Vinegar is an acid. Vinegar isn't just an acid, it's an acid in water. An acid in water, which is very, very important. Remember your chemistry. We have engineers here, mothers who've done chemistry. There's an acid. So the water in the vinegar acts like a host where the base and acid reacts, So during the reaction, when the baking soda is mixed with the vinegar, the baking soda base takes a proton from the vinegar acid. The reaction causes the baking soda to transform into water and carbon dioxide. The carbon dioxide is a gas which is released during the reaction, which gives it a bubbling effect. You saw that hissy when we mixed it. I showed you earlier on, and it expands, which will blow up the balloon, as you have probably seen, in this experiment. Cool, easy. This is an experiment your kid can do later on as they progress in their life. They can understand now exactly what's the chemical reaction happening here and why the other granulars of baking soda didn't dissolve. And now you also go into details of understanding exactly how much baking soda do you need and how much liquid of acid you need to mix those two to produce a certain amount of liters of gas, because you need to know how much gas you have. So later on in future, when they start learning chemistry, when it starts going ballistic and cool, when it's becoming harder, I call it ballistic and cool, then your kids and everybody who's doing chemistry will be able to now understand how many moles of acid do I need? How many moles of baking soda do I need? That's how chemistry works. That's how these people are producing chemicals, medicine. They're producing cool stuff that we eat, food. They calculate the amount of food in the amount of chemicals in the food, the amount of food value in the food, the amount, oh my God, it just goes on and on just from this simple experiment. Guys, that was my experiment that I wanted to show you. I hope you enjoyed. Now we are going to wait for Joshan's experiment. She's going to come with a very cool experiment. Guys, stay tuned, okay? So I'm going to put this away, and I'm going to bring in Joshan. I'm sure she's ready. So thank you so much for watching. So if you were close to me, guys, you are going to do this one next time. So those were my simple resources that I did. So let's pull up Joshan and let's see what she has for us. Hi, Joshan. Thank you so much for coming to Girls for STEM. So excited to have you. So go ahead.
Okay. I also have a very simple, very, very inexpensive project that you can do.
And Joshan, would you mind telling us what you do and who you are? Most people may see you for the first time, but you've been on this show for other times. So maybe if you can just introduce yourself and what you're doing.
Oh, hi, I'm Anjishana. I'm a manufacturing system engineer. Right now, I'm working for a company in quality who manufactures different products for aerospace, medical field, and just consumers. We do a lot of CNC machining, 3D printing, and we're starting up an injection mold where we're able to do that. So very exciting.
Yes. Let me see if I can put Jeshana, the whole Jeshana. 1 second, guys. I would like to put the whole screen so she can do. Let me figure it out. Hold on, guys. Okay, I'll just pull myself out. So I.
Oh no! Oh, I guess she pulled herself out. Okay. So I'm going to do a really cheap and inexpensive project, paper circuits. So this is what you can do to get your small children interested in STEM. I did it with my daughter and she loved it. And, she was trying to make her own circuit. So to start, you just need a diode LED. If you can see, it's a diode. It has a little LED light, and at the bottom, it has two little prongs. The long one is positive, the short one is negative. And then a little coin battery. You know the little batteries that you get? One side is positive, the other side is also negative. So how I got her interested is I put them together and I said, hey, honey, I can make this light glow. She was so excited. How did you do that, mommy? And then I got to explain to her, hey, this is a circuit, you know, it's direct and it goes like this, but you can do even more fun things with them. So what I have here, I have copper tape, but you don't need copper tape. You can use aluminum foil actually to do this. So I have some copper tape and a little piece of paper. So what I do is I put the copper tape, I cut it into two pieces, and I put it together on a paper.
Joshua, we can't see. Maybe if you can show us how we are doing it.
Oh, okay. See, I put it together on a paper. You can see, just put it in a straight line. And then I do the same thing for the other side. So you want to put them together parallel on a line so that your circuit can be even. And then if you want to add more lights to it, or, you know, there's other little electronics that you can add to it if you go to the electronics store and, you know, or you can find them around. Very simple. You do two little lines parallel together. And then you take this little light and you want to bend it two sides. So this is my positive side. I always like to remember this is my positive. So I bend it up. And then this is my negative. It's regular. And then I use the little paper. Oh, it's too far apart. I'm going to have to bend it further. I use these. And then you tape it onto the paper like this. So I have a little copper tape that I can use, and that's what I'm going to use to tape it on. But like I said, you don't have to have copper tape. You can do this with aluminum foil and regular tape. And it's very simple. The copper tape, you just pull it right off. It comes with a white little pack, and you pull it off. After you've pulled it off, your LED is attached. You want to get a coin battery and a little bit more tape to connect the circuits together, to connect the lines together. Like I say, you can use foil. It's very simple. You don't have to use. So what you want to do is, and I have one over here with two, actually. You can see I have two lights. I have the circuit, and then I have one battery. So what I do, and then it lights up. It's so fun, and they get to see it glow, and then you can put it in different patterns. So I was sleeping last night, and I showed my daughter how to do this. She told me she wanted to make a special piece of art. So she drew a little flower, as you can see. It's so adorable. And I helped her build her circuit, and then helped her connect the little circuit so it can glow. And we put a little LED, and then we have a flower that lights up, if you can see. It's so adorable. And then now she likes to keep it. And, you know, she wants to keep it in her room. And now she's so excited and interested. She wants to learn more about circuits. And she wants to go with me to the electronics store to see if we can find some more components and make some more things. This is how you get children interested in STEM. You help them to make things that are fun and pretty. And they enjoy it. They get so excited. They want to learn more and they want to build more. And now, like I say, I think I have a little engineer in the making, I hope. So that was my project. And like I said, you don't need copper tape to do this. You can do this simply with a little bit of aluminum foil and regular tape, any little coin battery and any LED. You don't have to have a tricolored LED. You can use any little LED that has a 2 diodes. As long as you know the positive goes to the positive of the battery and the negative goes to the negative of the battery. And you can, next time, what we're going to do is, these are in parallel. So as you can see, they're right on top of each other. This is what we call parallel. Next time we're going to experiment and see how to do these in series, so where we can do them connected around each other. So I hope you guys really enjoyed this and you learned a little. Like I say, it's very inexpensive, and this is how you get interested in STEM. You can do this at home by yourself. Well, not by yourself, with your parents, but all you need is conductive material, aluminum foil, and a little bit of tape and some diode LEDs.
Whoa. Wow. Thank you so much, Engineer Jeshana. We really, really do appreciate. That was so cool. I hope you guys learned something. Thank you so much, Jeshana. We're going to invite you, and you'll be seeing Jeshana a lot. She's an expert in educating girls, boys in science and technology. So we'll be seeing her a lot on this channel. Thank you so much, Jeshana. I really, really, really do appreciate it. Guys, oh, that was amazing. Guys, so we have our next astronaut to be. So she happened to be here. So we'll see how her plan is. She also made something. So let's see if we can talk to her for a few seconds, and then we'll see what she has for us. Hold on, guys. Hi, Priya. Thank you so much for having you. Oh, let us know where you are from, where are you bouncing from, and what are you doing, and what you have for us. I have your stuff ready just in case. So let us know, please. Thank you. Go ahead.
Awesome. Sorry I couldn't join in from home, but I'm here, guys. I'm Priya Abra. I'm currently a senior in high school, aspiring astronaut, and I'm currently doing astronaut training, hopefully eventually one day go to Mars. So currently, in my previous one of the videos, I talked a lot about what I've done for my training in different parts. I just want to share that recently I've also finished, graduated the Advanced Possum Academy, where we got to do a bunch of aerobatic flights. We got to test spacesuits and wear pressurized spacesuits. We also got to do training under hypoxia conditions, which is where you train to, be able to perform well in low oxygen conditions. So we had a lot of fun and amazing stuff in different aspects of our training. And yeah, I hope you guys enjoyed the little science video that I created.
Wow, thank you so much for supporting this channel. We really do love you, and people love your videos. Every time you do one, oh my God, it just goes viral. So, thank you so much. And thank you so much for what you're doing and your passion to go to space. I also happen to work for space missions. I'm very passionate about space, and just to see you as a young person trying to pursue being an astronaut, it's amazing. And guys, let's watch her space. She's so brilliant, and you're going to see the video that she has for us. So I'll let it play so people can enjoy it. Thank you so much, Priya.
Sounds good. Thank you.
Hello everyone, I'm Priya Abhiram, currently a high school senior and aspiring astronaut, and thank you guys for tuning in today to come hear the science experiment. We'll be having a lot of fun, and happy belated International Women and Girls in STEM Day. So without any further delay, let's get started, and I'll switch over to my screen. Hope you guys enjoy. Alright, so today we're going to explore a really fun website called Tinkercad and do a couple science experiments on it. And it is a really amazing platform that introduces you to many different aspects of science, from electricity to programming to computers to different devices. It has a lot of different tools that you can start learning through this show today and continue learning on through multiple resources that I can share toward the end. So it's an amazing platform, and it looks something like this right here. So you have all these different parts where you could build circuits, you could make make light bulbs light up, all done virtually on any device. And this device could be your computer, your phone, any device that you're viewing this show right now on. So you don't really need access to buying any specific materials, and the website is completely free to everyone. So I'm sure that all of you guys just need to be able to open up the link on the device that you're using currently, and you should be able to access a lot of different knowledge through this platform. So without any delay, let's get started with installing the software. So you could just go on to this link right here and create an account with your email account. If you are under certain age restrictions, you may have to use your parents' email account or any guardian's email account. So just have some sort of an adult supervisor help you out with this part if you need any help. And then you should be able to click circuits after signing in. So I have signed in to my account right here. And on the left, I see a lot of different stuff, like I said, that I could learn. You could learn to create your own 3D designs. And today we're going to be exploring circuits and electricity. So let's go ahead and click circuits and click create a new circuit. And before we delve into all the amazing things that Tinkercad has in terms of creating a new circuit, let's learn a little bit about what makes circuits and a little bit about electricity, shall we? So these are all the different parts, right, that come together to make your basic circuit. So what is a circuit? I will, give you guys some time if there's anyone, take a minute to think about it. So a circuit is basically usually some sort of a power source, like a battery, that is creating a flow of different electrons, different tiny particles through wires, and that is able to do different types of work, like lighting up a light bulb or turning on different appliances like your refrigerator or your stove or the lights in your room. All of this is powered by electricity. And electricity is caused by the flow of very tiny particles inside these wires called electrons that are all moving, and that motion is able to help us do all these sorts of cool things that is able to help us live today. So we have different parts, and the first one is called an Arduino. Your Arduino is basically like this board. If you guys have heard of a motherboard, you can think of Arduino as kind of like a motherboard for a circuit, just like a motherboard is to the computer, you would consider Arduino to be for your circuit. So it is where you would put all your code in, you would do your computer and your programming, and you give the instructions for the circuit and tell it what to do, and the Arduino takes those instructions and sends it to the circuit for the circuit to be able to do the necessary things, right? And then here you have your wires, which are what is where this different electrons and tiny particles are moving around to produce electricity. Here we have a battery, which is our most common power source, right? We need some sort of a way to power our circuit up. We have LEDs, which are really small, fun, different colored lights, and they're all available in the simulation again. Of course, we have a button, right? Your button, you could think of like a switch. You would turn your switch up to turn something on and down for off, right? So when here in Tinkercad, when you push the button down, your light bulb should light up, your circuit should work, and then when you turn your button off in setting, then it would stop working. So we're going to explore different things that we could do with that button over there. And we have a resistor, right? So if our power source, our battery is very strong, it is giving too much power, sometimes what would happen is that these LEDs over here could burn out and they would have too much electricity flowing through them. So what we have is something called a resistor, which reduces the amount of power that is flowing through your current so that the different parts of your circuit, like your bulb and your LEDs, they don't explode because there's so much power going through the wires. So you want to make sure that, all these different appliances like your computer or your refrigerator, they have limits on how much current can pass through those wires. If you put too much current, then all these appliances may not work. So we want to use resistors to regulate, to control that flow of electricity. So now that you guys have a basic understanding of the parts that go into, creating a circuit and creating electricity, let's go ahead and see. We'll talk about a couple more that are specific to Tinkercad. So we have the breadboard, which is a board that you could use to build your circuit, right? So it has all these rows of different holes that, you could connect wires in, and the rows underneath are, the board underneath is connected with each other. So you could put one wire here and then put it here, right? And then you could put another piece of wire here and put it down, and those two wires would be connected. So it's like a board where we could place all the different parts of our circuit, and it will automatically be connected together just by sticking it into the hole. So we'll see a little bit more of this practically be used on the Tinkercad simulation. We talked about our wires and our battery, our button and LED. So we have the resistors that restricts the flow of electricity, and we also talked about the unit that is used to measure your resistance is called ohms. And if you guys see the resistors, right, they all have different colors. They're not just random colors that, someone picked out to put on. These colors have a meaning, and it shows how much current is the resistor going to resist, right? So we have like this little chart that you guys can learn how to read, and based on the colors of this chart, you would know how much current is the resistor trying to prevent the flow of current. So the bigger your number in your resistor, the more current it prevents from flowing. Of course, we have our circuit overall, and this circuit that you guys see to the right is going to be our first basic circuit that we're going to build on Tinkercad, just so that you guys get a hang of the platform. And for those of you who are super excited to challenge yourself and take that a step further, we would have another more complex circuit coming up, which has an Arduino, so it would also take you into programming and coding. So before we go into that, let us go ahead and get started with building our first circuit on Tinkercad, which is going to be a lot of fun. So let us go here, and if you guys see to the right over here, you have all these different components, right? And they are always adding new components to software a lot of times. So for this purpose of a simple circuit that we're going to make, we're going to search. You have a search bar right here. You could search any of the parts that you want. We're going to take out a coin cell battery like that. After we take out a battery, you could see that the battery itself has wires, right? All you need to do, delete that. So all you need to do is click on it once and then move it up and then click it again, and it stops right there. And then you could just continue flowing, right, making your battery wires flow. And then if you want to stop the wire, you would just double click right there, and it should stop. I guess it is not. Let's try that again. Let's try first taking all the parts out, and then we can wire it together. So we have our battery. Next, what we need is a resistor. So we're going to go back here and type resistor, right? And we have a resistor right here, right? We're just going to place all the parts out, and then we're going to need an LED. Let's wait for it to load. There we go. LED. There we go. Now we're going to assemble our parts together. Just line it up, right? Take our resistor here, and we line that up just like that on the image. And now I think we should be able to connect our wires. So you would have to have your components out before connecting your wires. So click on one end, right? And then just drag it up, and then click on the end of the resistor, and boom. Now with this wire, you could also do a lot of fun stuff with this wire by clicking on this wire. You can change the color of it over here, right? And you have all these different colors, and we'll talk about what some of the common colors mean, right? So for example, red is usually used to signify positive, the positive side of a battery, right? So right here it says that's the positive side and that's the negative side. So the current coming out of the positive side would usually be red, like that. And then we go from the resistor to our LED, and then we can go from our battery and connect up to the other side, just like that. And now this side would be considered negative. So a circuit usually has a positive side and a negative side coming out of your battery, right? So now that we have this little circuit made, right, so we have your power source that's giving you electricity that is passing through a resistor, and it just looks like our image. So let's try clicking start simulation. And ta-da! Do you guys see that? That light bulb just light up. Just pay attention to the light bulb. Look at that. That light bulb turned off. Let's start again. Light bulb light up and off. So if you guys were able to make this successfully, congratulations. You have just made your own circuit experiment, but online, right? So you don't need, the advantage of this is that, you know, if you don't have batteries or resistors or LEDs or breadboards at home, you don't really need any materials at home. All you need is this free website, and you can build all sorts of complex circuits and ideas and etc. So this is just, you know, your basic amazing circuit that makes your LED light up and stop. And right now I'll be just pausing the video, and then the next one we will go into a more advanced circuit with computer science and programming for those of you guys who are interested and willing to challenge yourself. Alright, hello everyone. This is a continuation of the electrical and computer programming science experiment on Tinkercad. So now we'll be learning a little more cool concepts in programming, right? So 4 basic concepts of programming that are the same regardless of what type of programming you do. You know, there are different types of programming. There's C++, Java, Python, but the basic idea of what are variables, conditional statements, loops, syntax, pretty much are similar across the board. So let's go ahead and learn what these are. Variables, right? So as the name states, variables change, right? So unless you assign it a specific value, they can take on any value, right? So we have different types of variables. We have integers, which are whole numbers. We have char, which is characters, and then we have string, which is like a word or a phrase, right? So int stands for integer, right? And then the name of your integer is going to be pin, which is equal to 6. So every time you say the word pin, the computer is going to think that pin stands for 6, right? And the same applies for character. It would think that whatever that you assign it to is going to be one single character. And then string, it would think that whatever you assign it to is going to be a word or a phrase. We'll look into this a little more detail. And then we have loops, right? So what are loops? It's basically if you want your program to do a specific thing again and again, you can just put it inside a loop. And what it will do is that it's going to read that statement multiple times, how many ever times you tell it to read that set of program. So that way, you know, if you want your light bulb to blink 5 times, then you can just put that into a loop and it'll just go through the program 5 times rather than you having to type it out each and every single time to make the light bulb blink those many times. So it's a cool function, right? We have that lets you do it again and again, run that set of code again and again multiple times without having to rewrite it. Now, conditional statements. It's like, hey, if this is the case, then do this. Else if this is the case, then do this. else do that. So let's take a simple example, right? Oftentimes we want to go out and have fun, right? So if the weather is sunny, let's go play soccer. Else, if the weather is rainy, then stay home, right? So that's very basic, you know. If the button is pushed down, then turn the light on. Else, if the button is up, then keep your light off. Or similar to a switch. If the switch is turned on, turn your device on. And if the switch is turned off, then turn your device off. Those are basic conditional statements. If this is the condition, then you would have to follow this. Else, if this is the other condition, you would have to follow that. So now that we have learned what, basically it takes, this is going to be the code that you guys are going to type into your Tinkercad. So let's go back to Tinkercad. And here is your space. We're first going to start off by getting everything we need for our circuit. So let's see. We're going to need a breadboard. Small breadboard should work. It comes out to be pretty good sized. Then we have a Arduino. Alright, we're going to put that right there. If at any time, everything's on top of each other, and you need to turn it, you could just click on your device, click on your object that you want to turn, and then there's the little arrows here. So it's basically helps you, not that one actually. You click on it, and then it's this one right here, and it helps you rotate like that. Now you have it straight up and down, okay? And then we have, let's see, we have a couple resistors, LED, and a button. So I'm just going to put this on slideshow mode. It is really important that you guys follow the exact holes and the setup of this, because this is how the code is what the code relates to, right? So we are telling the Arduino to read off the wire at PWM port 6. So instead of 6, if you guys put this wire somewhere at 7, then your code or your circuit is not going to work, because we are telling it to read off of 6 in our program. So it is important that you guys follow this layout exactly, or if you don't, you would have to edit your program accordingly to make sure the instructions are correct. So I'll just leave this on this presentation for a quick minute. You guys can feel free to pause the video right about now and try to just build this, and I'm going to be showing you guys now how exactly to build it. So let's see. We have wire coming from 6 out to 10, like that, right? So I'm just going to show you guys one quick example, and I'm going to build it real fast. There we go. 6 down, out. Let's give it a minute to load. All the way up to 12 right there. There we go. Should that be 12? Oh, no, it's actually 19i. Okay, so if we want to change the location, we would just click on the tip, and we can change it anywhere we want, just like that. You just have to click on these different nodes, right? So we wanted it right there, okay? So now we go back and we continue building the rest of our circuit. So I'm going to do that real quick, and you guys can take a look at the screen and try to build it yourself. Alright, so here it is. I basically just took this, right, and I rebuilt this, following the same ports, the same wires. Just note that, the main difference between these are the colors of the wires. So this is where I also wanted to mention, right, the color of your wire is not going to affect how well you're able, your electrons are able to flow, or how strong your current is, or how well your electricity is able to flow. The color is just for your own way to distinguish what type of wire does what function. So it is honestly up to you to have fun with the colors of the wire and the different, the wire types of it, but just as long as you make sure it's all connected properly. So now that we have our entire Arduino and breadboard set up, we're going to take the code that is on this slide over here. I'm going to just present it like this, and you guys should be able to just type this exactly onto the Arduino code, right? So when you go on Tinkercad, when you have this on the top right corner, you have a button that says code. And you have different types, right? There's blocks plus text, and text. You want to click on text because we'll be coding with text, right? We're typing out our code. And if you guys see, this is the same code that is over there. So I'm just going to zoom in for you guys to be able to see, and you can take a minute to again pause and just type down all of your code onto your Tinkercad code simulator, right? So once you type all of this exactly, and while you guys do that, I can go ahead and explain what's happening, right? So we are assigning integer LED 6, right? So LED equals 6. So because that's our first wire here is coming out of 6, so this is what's going into our LED, and then our button is going to be red out of 5. So whoops, let me just zoom back out, let it load. Let's try to move this over and zoom in a little, zoom out a little. There we go. I think that should be good. All right. So, and then we have another variable called button state, and this button state is the variable that will determine whether the button is pushed down or the button is pushed up. Okay, so we have these 3 variables, and we're setting it up so that when the mode when the button is on, it is the LED's on. Button is pressed down, the LED's on, and the button is released, the LED's off, like that. We're setting that up. Now here we're making a loop so that we don't have to write the same code each time, every time we press the button and every time we release the button. Right? So we make a loop so that the program automatically knows that whenever the button is pressed, it comes to read this and learn from this. So the state of the button, we're going to ask a digital read is a function that tells the Arduino to, okay, go look at what state the button is. Is the button down or is the button up, right? Is the button pressed or is the button released, right? So if the button state is high, then LED is high. Else if the button state is low, LED is low. So here are our conditional statements that we talked about. If it is high, then LED is high, and else if it is low, LED is low, right? So high LED high and low LED low are just fancy way of saying on and off. So it's just fancy ways of saying that if the button is pressed down, the LED is on, and if the button's released, then it's off. It's just a fancy way to write that. So once you guys are done typing this out in your code box, right? So you could click right here, right next to code, see the button Start Simulation. When you click Start Simulation, you will no longer be able to edit your circuit. All you can do is to press the button. And ta-da, look at that. Observe your LED as I press the button. Boom, it turns on, and now it's off. It's on and off. Isn't that so cool, guys? You guys just programmed your own Arduino and electrical circuit to turn your LED button on and off. Should be super proud of yourself. So again, press it down, on, and off, right? So I hope you guys enjoyed learning this, and I just want to mention a couple things that if you guys, when you click Start Simulation, if you see anything red over here, then those are probably a couple error messages. Just go back and double check to make sure you typed in your code properly. Note that it is case sensitive, so your it has to be the correct lowercase and uppercase letters. If my I here was capitalized, it's not going to work. If I have 2 spaces instead of 1, that may create an issue later, right? So just make sure everything is perfect and exactly like this. And if that's the case, then you shouldn't have any errors. And then over here, if this is correct and you don't have any red lines here, but it's still not working here, then just double check to make sure all your wires are in the correct place, right? And if it's not in the correct place, click stop simulation, double check, adjust the different positioning of your wires, click start simulation again, and boom, when you press it down, it's on. When you let it go, it's off, and the same applies. So I hope you guys really enjoyed that. And before finishing off, I just want to say that this was just the beginning of learning electricity, electrical engineering, and programming and computer science, and seeing how all your different types of sciences come together to do the most simplest of tasks that we take for granted, right? And I hope that you guys take away by seeing this that just turning on one small LED light took up so much of science. Imagine how much science is around you in your day-to-day life. So hope you guys are inspired to continue learning and making new things and, playing around with your hands. And this is a really cool platform because you have all these different tools. You don't need to buy any of it. You have it all for free in this software. You have all these different types of components. And when you go to Tinkercad, you can also see some of their sample components that they have. Let's see, some of the other cool, really fun projects that you could make, like really big circuits that you can make. Once you get more advanced, you could obviously watch YouTube videos about just learning Tinkercad, and once you get advanced, you can do really cool stuff like Christmas lights, and you could add sounds and music and noise to your circuit. You could do so much of really amazing stuff. So I hope you guys enjoyed this learning experience, and I could play this as a final thank you, and have a great rest of your day.
Wow. I hope you guys enjoyed. I had so much fun. It brought memories of programming, but in a very simple way. She explained. That was really, really gorgeous. Oh my God. Thank you so much, Priya. Again, Priya, she's an upcoming astronaut. Guys, you're going to see her most of the time. She'll be coming here. So leave comments for her. Leave questions for her. She can come back and answer them. If you have questions about her astronaut career, and even what she was explaining here. So again, she was explaining how you can do programming, how you can do, you can also participate to understand electricity. If you want to be an electric engineer, simple circuit that she created. And also she created if you want to learn more about programming in a very simple way. Oh my God, I think I can follow that now. You make me, Priya, want to buy my Arduino set again. I remember we had those sets before. And guys, oh my God, I had so much fun. So guys, thank you so much. Again, we were expecting one more engineer to also present, but unfortunately he's been having issues with the with internet. But we can still get him do some other time, not only today, but he can still come and present that experiment earlier on. And guys, this platform, we are learning from each other. We are also teaching kids around us so that they can learn. If you have questions, kids, ask, request for any type of experiment that you want us to help you understand, even perform. Again, today we were belated commemorating Science Day. It was yesterday, but today we thought we could come here and just spend some time with you guys and just enjoy looking at experiments. So I wanted to see if Joshana can come. Joshana, are you ready to come, just to come say something to the audience? Hi, Joshana.
Hi.
Yes, so thank you so much for coming. And do you have anything you want to share or say to the audience? Please feel free.
Well, I can share that the first way to get your child introduced and interested in STEM is to, well, read to them or to watch with them. Me and my daughter love watching videos.
Let
And
me
usually
also
she likes,
bring Priya up. I hope she'll be she's available. We'll see if she's available. She's gonna come up. Yes, continue, Jeshan.
if we're not reading with her, we're watching videos with her about animals, engineering things. I read the news with her and, she get her interested. Back when I was in college, I took her to class with me, as you can remember. So
Yes.
she's always been in the environment of being around STEM and engineering. And I wasn't, so I'm very excited to see that she has this high interest in things and finding new ways to get her interested every day. So hopefully, now that she already has that a part of her, it'll grow on her as she gets older, and it will branch out into other things that she enjoys doing. Because, like I say, a lot of us, we didn't grow up with engineering and STEM. We didn't know anything about it. We had to learn from ourselves, and we had different journeys. So getting her to experience this and getting her interested and finding out what she likes and trying to find ways to further her is very fun, and I enjoy it. And we find new ways to do new things every day.
Wow, that's so interesting. I always try to share that it's very difficult when you grow up, and that's when you see what a test tube is in your life. When you start doing chemistry, that's when you see what are chemicals, what is acetic acid, and you didn't even know. You used to eat vinegar, putting it on your fries and salad, but you didn't know that it's an acid, that it's there's a acid inside, and it can also be used as a chemical. So what I'm trying to say is we need to expose our kids to these science as early as possible. Just like Joshana, you're saying, you've been exposing your beautiful, or she has a beautiful daughter. You guys, one day she's gonna come here. We just love her. To expose her to science at her early age, guys. She's about 4, 5. How old is she?
She's 7 now.
Yeah, she's about 7 now, but she started, because we went to school together with Joshan at the university. She started exposing her to science at very early age. And that's why we are crying out here, guys, to expose our kids, as early as possible. For example, I didn't understand what a test tube is. I never saw it. When you're growing up, you don't even understand what it is. You don't understand chemicals. When you see the chemicals for the first time, you get so uncomfortable. You're so scared when it's just vinegar, and it's just bicarbonate soda, and this baking soda. There are so many carbonates that can be converted and changed to different types of chemicals. But if we don't tell our kids that these are just things that we have around us, it's very difficult for them. When they see them for the first time, they start shaking. They're in the lab. Oh my God, this chemical. It's not, it's just something in our environment. So I'm just trying to say, if we encourage our kids as young as possible, it's really easy for them. I think Priya may be busy. She's quite a busy person. So if we expose our kids as early as possible to these environments, it's very easy for them. For example, see, Priya was talking about programming. Some kids may pick it up even when they are young, because she explains it in simple terms. But when you come and start hearing about this programming when you're older, you don't even understand what is a variable, what is a loop. She put it in a simple term. A loop, it's just when you want something to repeat again and again. One of the repetitions is turning the light on. Where do they repeat a light on after? You can even give it a condition. You light up when something this happened. You can program like that. For example, in the factory manufacturing, where they're making cars, or where they're making, whatever they're making, something goes wrong, you program the PLC. You tell it, when this happens, turn yellow. When this happens, turn green, meaning go, or something. So they combine all these things in different things. So anyway, I can go off on tangent, Joshan. But Thank you so much for coming, Joshan. I really appreciate. And I think we're gonna come to the end of the show. And guys, if you have any question, leave a comment for us. Leave a comment for Joshan. Leave a comment for Priya. They'll come and answer these questions. We are here to encourage girls to pursue science and technology. We are here to showcase other engineers. Joshana is an engineer. I am an engineer. Priya is an upcoming astronaut, and many more others that we bring here, so that we can just feel comfortable to enter this career in STEM. So thank you so much, guys. Remember to subscribe, and ciao ciao. See you some other time, and bye.